Hi everyone and welcome back. Today we're going to take a look at Unit 1.6, Dividing Rational Numbers or Dividing Fractions. This is page 114 in the textbook. So go ahead and write today's date up at the top for me, please. And let's take a look at the two objectives for today. So I think you're going to find this pretty easy overall. It does mirror the last lesson, which was multiplying fractions. So let's take a look. We're going to divide positive and negative fractions using multiplicative inverses. We got a big word today. So divide positive and negative fractions using multiplicative inverses. You may know it better as the reciprocal, okay? So if you want to write that down, also you can put that as the reciprocal. And we're also going to divide algebraic fractions. Okay? All right, so let's take a look here at the first one. We're actually going to have to first figure out what the heck the multiplicative inverse actually means. All right, in this case, it just means to literally take the opposite, which is what inverse is, take the opposite of what it is. Now we're not talking about negative and positive opposites, we're talking about the actual opposite of a fraction, which is to flip it over. So for this one, we have 7/16. It literally means to flip it over upside down. So this is actually 16/7. Now, one thing I do want to caution you with is don't put the equal sign because 7/16 is not equal to 16/7. If I give you a pizza that was cut into 16 slices, most of the time they're cut in 8, right? Okay. If I cut them all in half again and I give out 7 pieces, okay, or there's only 7 pieces left. Sorry, I said it wrong. If there's only 7 pieces left, that's not the same as if I give you a pizza cut into 7 slices, but yet there's 16 slices. Okay, that means something totally different. You would have a whole pizza plus some extra, right? Okay, so don't put the equal sign. All right, next we have a mixed number. So kind of think back to the previous lesson. What do you think we probably have to do with a mixed number? We're going to have to change it into improper. Okay, so we know it's negative. All right, so let's put equals first because this one actually is equal. So what does it equal? Well, remember, you take the bottom times the whole number, so 3 times 6, which is 18, and then you add the numerator, so that's actually 19. So it's actually negative 19 over 3. Now we need to flip it, so it's actually negative 3 over 19. Don't mess up on those, okay? Don't miss the easy ones. That's one of my sayings that I kind of like to say a lot in class, is don't miss the easy ones, all right? So don't miss the easy ones. Make sure you take your time with them. Everyone gets in a hurry and just wants to flip, 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 and that's great. But make sure you take your time on the mixed numbers. Don't make silly mistakes, okay? All right, let's go ahead and pause and go ahead and do the got it question by ourselves and come back to me just as soon as you're ready. And let's take a look. So this one is simply negative 9/7. And 1b, we have to first convert it. So we need to do 2 times 12, which would be 24, plus 1 would be 25. So I end up with 25/12, but then I have to flip it, so it's actually 12 over 25. And that's it. All right? Okay, now we're going to get into the meat and potatoes, as I like to say also, of the section, or the main part, which is going to be working with these fractions and how to divide them. So what we need to do is we are going to use the reciprocal or the multiplicative inverse. Okay, the reciprocal is the easier way to say it, which is flipping it over. So our rule is called keep, change, flip. Keep, change, flip. All right. I do have a vocabulary video that I'm going to show you. So let's take a look at that.
Yeah, you know how this go. Keep, change, flip. Simple, right? Divided fractions. Vocabulary. Let's go. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip. Yeah, that's the action. Everybody's gonna know how we're dividing fractions. Dividing fractions is easy, that's no lie. You just flip one, yup, then you multiply. Don't flip both, because that'll be strange. You need to keep one exactly the same. Yeah. Then the sign gets changed, division to multiplication, that's okay. Then flip the second fraction like you're on a grill. We multiply what's left, that's really real. Take 3/5 divided by 2/3. Keep, change, flip, that's the word. Keep 3/5 the same, change the sign so we multiply, that's the game. Flip 2/3, we get 3/2, then we can multiply, and so should you. 3 times 3 is 9, 2 times 5 is 10, 9/10 can't reduce it, that's the end. Why do we flip it? I'll explain the math. Dividing by 2 is the same as multiplying by half. 20 students in your class divided by 2 would be 10 students. All we can do, 20 students in your class times half is 10. You'll see, you'll get the same thing at the end. Dividing is multiplying by the reciprocal. Keep, change, flip, yeah, that's the simple rule. Keep, change, flip, yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip, yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip, yeah, that's the action. Everybody's gonna know how we're dividing fractions. Keep, change, flip, yeah, that's the action. Everybody's gonna know how we're dividing fractions.
All right. So that's one of my favorite ones there. I just really like the video. So that's the rule. Keep, change, flip. Yeah, that's the action. Everyone's going to know how we're dividing fractions, or everybody, whichever way it is, but whatever. Okay, so we're going to find each quotient and write in simplest form. So hopefully the little video there gave you a little quick tutorial, and this won't seem so bad. All right, so here we go. So let's take a look. So we're going to do keep, change, flip. All right, so I like to actually write out keep, change, flip, so I kind of remember what I'm doing here. So we're going to keep the first one. We're going to change it to multiply, and then we're going to flip it. So this is where that multiplicative inverse or reciprocal comes in. All right, now for today, I'm actually going to show you how to cross cancel, because you should already know how to multiply fractions. That shouldn't be a big deal. What I want to teach you is how to save yourself a lot of time. All right, that's always the biggest thing that I hear in math all the time is, well, I don't like math because it takes too long, or are there any shortcuts? Yes, there's a ton of shortcuts in math, okay? Believe me, there's a ton of shortcuts. I'm not a genius, but I just happen to know a lot of the shortcuts, so it makes it look like I'm a genius, all right? So here we go. All right, we kind of practiced in the last one. What you do is look diagonally. As long as one's on top and one's on bottom, all right, it actually doesn't even have to be a diagonal. Just look on the top and look on the bottom. Is there anything that you can reduce? So in this case, we have 12 and 9 diagonal from each other, okay? What goes into 9 and into 12? Well, the answer would be 3. So we're going to reduce each one by 3. Reduce means to divide, whenever I say that, okay? So we're going to divide by 3. So that would be 3 here. 3 goes into 3, or 3 goes into 9 3 times. 3 goes into 12 4 times, all right? Now, we have all prime numbers and 1, so that's as far down as we can go. Now we're going to go back to what we did yesterday. So we're going to do 1 times 4, which is 4. 3 times 5, which is 15. And that's it, okay? It's already reduced for you. So if you reduce now, you don't have to reduce later. And that's where people kind of get hung up on stuff is multiplying is great because you can just multiply your way across, but then the numbers get so huge, you're like, I don't even know what to do. Okay, and even on that one, I kind of started to get stuck on myself yesterday, or on the last lesson. Okay, let's take a look at letter B. We have 3/7 divided by 8. So again, keep, change, flip. Yeah, that's the action. Okay, so 3/7 times, and this is actually 8 over 1, so now we're going to flip it, so it becomes 1/8. Okay, look up and down. Okay, I kind of like to think of the fraction bar as like a boundary or a border. Okay, as long as one's above and one's below, they're on opposite ends, so you can take each other out. All right, so 3 over 7, 1 over 8, not going to work. 1 and 7 and 3 and 8, nothing's going to work there. Okay, so this one we just work out. So 3 times 1 is 3. 7 times 8 makes it 56. All right, if you think you got it, go ahead and try 2A, B, C, and D. If you're still not quite sure on how to do them yet, what I'm going to actually do is I'm going to do 2A, then I'm going to do 2C, then 2B, and 2D, because I really want you to try these on your own as much as you can. All right, so let me scroll down a little bit here. And let's try these. Okay, so we're going to do keep, change, flip. So we're going to do 1/3 times 15, let's do it that way, 15 over 7. All right, now this one does have canceling in it. So when I look diagonally, I have a 3 and a 15. 3 goes into both numbers, so 3 goes into 3 one time, and it goes into 15 5 times. All right, and that's it. So we have 1 times 5, which is 5, 1 times 7, which is 7, and there's my answer. All right, I'm going to jump over here to 2C and do one more of the whole number, and then if you're still not totally sure yet, then I want you to try them on your own with 2B and D. All right, so let's try 3/4 times, and again, this means 11 over 1, so I actually need to flip it, so it's 1/11. Okay, now there's nothing I can take out because everything is either prime or it just doesn't work. Okay, so we'll have 3 over 44. Okay, so if you struggled with those first ones, you should be pretty well ready to go now. So go ahead and pause it and try the other two on your own. If not, we're just going to continue on. And if you are pausing, then just go ahead and pick up as soon as you're ready. All right, so let's take a look. So we have 5/8 divided by -3/4. So that'd be 5/8 times, and then it's going to be -4 over 3. So this one will reduce, okay? 4 goes into both of them. So this will leave us -1 and a 2. Be careful when you're canceling with negatives. All right, always make sure you put the negative back in there. Let's see, and I think that's it. Yeah, so we have 5 times a -1, which is -5, and then 2 times 3, which is 6. Okay, so I get -5, 6 for that one. All right, let's come over here to 2D. So I have -6/7. We're going to change it to times, and that's actually over 1, so we're going to change it to 1/12. 6 will go into 12, so 6 goes into -6, -1 time, and it goes into 12 2 times. -1 times 1 makes it -1. 7 times 2 makes it 14. And that's it. So we have -1 14th. All right. They're kind of fun. I don't know why. It's like multiplying and dividing fractions just seems fun to me, but maybe because I'm a math teacher, but nonetheless. All right. Let's continue on. All right, so this time we're going to have mixed numbers. Now think back to the previous lesson. What do we always have to do whenever we have mixed numbers with multiplying and dividing? We got to change them to improper, okay, before we do anything else. Okay, so let's rewrite the whole question before we even start. So we have 3 times -4, which is -12, and then we have 12 plus 2, which will give us 14. So this is actually -14/3 divided by, and then we have 9 times 3, which is 27, and then plus 1 makes it 28. So it's actually 28/9. Now, if you notice, I did not do keep, change, flip. I just want to convert them into improper first. Don't try to skip steps yet. You can do that later once you've really got it down. But if you try it now, you're probably going to get it messed up. Take your time with these. Don't get overwhelmed. All right? Now let's do the keep, change, flip. So we're going to keep it, change it, now flip it. Because what almost always happens is I've got people in the first day, they're like, oh, I've got this. I'll just start on right away. What do? They do keep, keep, keep. Or they'll do keep, change, keep. All right, no, you got to remember the keep, change, flip in there, or they'll end up flipping everything, which doesn't help at all. All right, take your time, rewrite the question first, then apply the keep, change, flip. Don't try to do a whole bunch of stuff at one time. All right, now this one has lots of canceling in it, which is great. So we have 3 with the 9, so 3 goes into 3 once, goes into 9 3 times. 14 also goes into 28, so it goes in -1 time here and 2 times here. So what I'm left with is -1 times 3, which is -3. 1 times 2, which is 2. All right, -3 halves. We know that that's -1 and a half. Okay, and it's that simple. All right, if you are ready, let's go ahead and turn the page. If not, go ahead and pause. Okay, let's go to 3A and B. So go ahead and pause it if you haven't already done so, and let's try these on our own. All right, let's take a look here. So we have 6 3/8, so that would be 48 plus 3, which is 51. So 51/8 divided by, and then 16/17, so -17/4. All right, let's go ahead and apply the keep, change, flip. So that's going to give us, I'm trying to figure out, let's see where I should write this. I should have went farther over. I'll just do it here, it's fine. Okay, so it'll be 51/8 and then times -4/17. Okay, one thing I didn't mention earlier, but you probably already picked up on is I always keep the negative with the top number, and that's just so I don't forget it whenever I'm multiplying. Okay, I think I kind of told you yesterday is keep the negative with the top, but try to do so. It does help out a lot. Okay, so we have a 4 and an 8. So 4 goes in to -4, -1 time, and it goes into 4, or 8, I'm sorry, 2 times. And we have, let's see, 17 times 4? No, 17 times 3. 21. Yeah, 17 times 3. Okay, so 17 times 3 is 51. So we're going to go in 1 time here and 3 times here. 51 is not prime. Everybody likes to think 51 prime. 51 is not prime. 17 times 3. All right, so we have 3 times a -1, which is a -3. 2 times 1, which is 2. Well, that was great because that makes it -1/2. 1.5, sorry. -1.5. All right, let's look at 3b this time. So we have -6 and 4/5 divided by -2 and 2/5. So we have 6 times 5, which would be 30, plus 4, so that's -34 fifths times, and then I have 10 and 2, so 12, so -12 fifths. All right, now let's keep, change, flip. Again, don't try to do 2 steps at once yet. It's still too early. Just get this down. Day 2, you guys can try it again with skipping steps. And then let's flip it so it's going to be -5/12. All right, looks like we do have some canceling here, which is great. So we can go down by 5. So that's 1 here, -1 here. 12 and 34. 12 won't go in evenly, but they do have at least a 2 in common. So that would be a 6 here and -17 here. So we have a -17 times a -1, which is going to give us +17. 1 times 6, which is 6. And we do got to convert that. So 6 goes into 17. 2 times, which is 12. There will be 5 left over, so 5/6. So 2 and 5/6. All right, let's go to example 4. It says Tessa feeds her dog, Roscoe, 3 3/4 cups of dog food per day. If she buys a bag of food that contains 165 cups, how many days will the bag of food last? All right, so I know many of us have pets. I have a rabbit right now, and she doesn't really eat a whole lot of food, but anyway. All right, so if we have a huge container, we need to figure out how many days worth it will actually last us. So we're going to take 165, and we need to split it up into 3 3/4 sections. Okay, so that's going to be 165 over 1 divided by, and then we have 4 times 3, which will be 12, plus 3, which will be 15, so 15/4. All right, now we're going to keep, change, flip. So we're going to do equals out this way, so we'll do keep, change, flip. All right, so let's see here. How many times does that 5 go into 165? So it'll go in 3 times, and then that'll give us 15 with 1 left over, so 15, so 33? 33 times? And 1 time there. All right, then we got 33 times 4, so that would be 12, carry the 1, be 132 over 1, and that just is 132. Okay? Now, we need to actually figure out what exactly this is, and what did I do wrong? That can't be right, 132 days. Oh, I see what I did. Sorry, back up. Just a little bit. That should have been 4 over 15. My bad, my 1 didn't go in there. Sorry, 4 over 15. Okay, let me fix my math then. There we go. All right, so we should have 165 over 1, and then we should have 4 over 15. So 15 goes into 165 11 times, which makes more sense. Then that goes in 1 time there. Okay, that makes more sense. And then that's going to give us 44 days. All right. My bad. Sorry. Again, I said I make mistakes here or there. It just happens. I get lost in all the numbers. All right, so 44 days the food will last. All right, let's go ahead and try number 4 down there at the bottom. Go ahead and pause it. And just come back to me as soon as you're ready. And let's take a look. It says a box of cereal contains 15 3/5 ounces. If one bowl holds 2 2/5 ounces of cereal, how many bowls of cereal are in one box? So again, we're trying to take the whole amount and split it up into smaller sections. So let's go ahead and skip at least one step here and convert this right away. So let's do 15 times 5, and that will give us 75, and then plus 3 more, so that'll be 78 fifths divided by, and then we have 12 fifths. All right, let's keep, change, flip, so that'll be 78 over 5. Change the times, and then 5 over 12. So my 5s are just going to cancel to 1. That helped out a lot. And does 12 go into 78? I don't think so. No, because it goes in, but let's see, does it have 6 in common? Nope. I guess just 2. So that'll be 6 here and 39. All right, so then we got 39 times 1, 39. 1 times 6 over 6. So that's going to go in 6, and that'd be 36. So there'll be 3 left over. So 3, 6, which is 6.5. And that would be bowls. All right, so 6.5 bowls. All right, now let's go to the second part of the objective, which is to work with algebraic expressions. So everyone seems to panic on these. These are actually one of my most favorite things to work on. I don't know why, I guess it's just the math teacher in me, but they look super hard, but when you understand what it is, it's really, really easy, okay? And it's actually not that much math, contrary to belief. So what we have is 5 over 3ab divided by 15 over abc. So we're just going to do keep, change, flip exactly what we were doing before. So this is still going to be 5 over 3ab. Then we're going to change it to times. Now we're going to flip. So it's going to be abc over 15. Well, what happens is you're actually going to cancel the way we normally would. So 5 will go into 15. So it's going to go in 1 time here and 3 times here. Once you've done the numbers first, now we start canceling letters. So as long as there's a letter on top and on bottom that match, you can cross them out. So in this case, we have an A that goes away, and we have a B that goes away. Now, if anything completely cancels, remember, you always have a 1 there, okay? It doesn't turn into 0, it turns into 1. But I usually don't show that just because it gets a little monotonous whenever you're doing a whole lot of these, all right? And then we're done. You can't cancel the 3's, all right? That's a common mistake is people see 3 and 3 and they want to cancel. Remember, 1 needs to be on top and 1 needs to be on bottom. They don't have to be diagonal from each other, but 1 has to be on top, 1 has to be on bottom. Okay, again, I kind of like to think of it as like borders and stuff. You don't take out people on your own side. You only take out the people across, right? Okay, so let's multiply here. So we have 1 times and then c. So 1 times c, anything times 1 is itself. So in this case, it's just c. And then we have 3 times 3, which is 9. So out of all of that, we end up with c over 9. Okay, c over 9. Now, I know this is weird, and a lot of people about go cross-eyed whenever they see it, but take your time, all right? If you think you've got it, go ahead and pause and come back to me. If not, let's try 5A and then pause and then try 5B on your own, all right? I really want you to try to get some of these on your own. All right, let's take a look here. So we have 5AB over 6 divided by 10B over 7. So let's do keep, change, flip. So it'll be 5AB over 6 times, and then 7 over 10b. All right, let's get numbers first. You don't have to do numbers first, but I just find it's helpful. All right, so we have a 5 and a 10 we can take out, so that's going to go down to 1 and a 2, and then I have a b, and that's going to be it. So we have 1a times 7, so 1 times 7 is 7, so 7a. And then I have 6 times 2, which is just 12. So I end up with 7a over 12. All right? So if you just did that one with me totally, go ahead and pause it and try 5b on your own. If you've already done 5a and 5b, then let's continue on. All right, so for this one, we have mn over 4. Change the times, make it 8 over m. And then from there, we need to cancel, so it's going to go down to 1. And 2, and then my m is going to cancel with my m. I'm left with n times 2. Now it's actually 2n. The number always goes in front of the variable. Okay, it's never the variable then the letter. It's always the letter, or it's always the number and then the variable. Okay, and then we have 1 times, nothing was actually here, so I should have put a 1 there. All right, so 1 times 1, which is 1. Anything over 1 is itself. So this is just 2n. All right, so I know it's kind of weird. I really enjoy doing these. I don't know why. It's kind of like a little game, I guess, into what I can cancel. But that's it. So remember, keep, change, flip. Yeah, that's the action. Everyone's going to know how we're dividing fractions. All right. Thanks so much for watching, and I'll see you next time.